In one recent conflict, more than 150 interceptor missiles were fired in just 12 days. The problem? In normal times, manufacturers only produce around 40 per year. That means in less than 2 weeks, several years' worth of interceptor missiles were used up. And this is exactly why you keep seeing headlines about air defense systems running out of missiles. But the real reason this happens is not what most people think. It is not simply a matter of money or poor planning or someone forgetting to order enough missiles. The real reason is much more fundamental. It comes down to the gap between how fast missiles can be fired and how fast they can be built. And that gap is growing wider every year. Let me explain how we got here. First, you need to understand what an air defense interceptor actually is. When a country detects an incoming missile, something launched toward a city, a military base, or a ship, it fires back with its own missile. Not to attack anyone, just to stop the incoming threat before it arrives. That defensive missile is called an interceptor. Now here's the thing that surprises most people. These interceptors are some of the most expensive and complex objects ever built. A high-end interceptor can cost $10 to $15 million. Each one. That is not a typo. One missile. $15 million. Why so much? Because these missiles have to be extraordinarily precise. They have to detect a target moving at several times the speed of sound, calculate where it will be in a few seconds, fly toward that point, and either collide with it directly or detonate close enough to destroy it, all within a matter of seconds, sometimes at altitudes where the air is almost gone. It is not like building a car or a plane, where you can use standardized parts and a traditional assembly line. Each interceptor is a custom-built piece of precision engineering, with essentially zero margin for error. If it fails, the incoming missile hits its target. So when a country has an air defense system, it typically has a limited stockpile of these missiles. That stockpile is meant to last for years under normal circumstances. But normal circumstances do not include sustained missile attacks. Imagine you have a stockpile of 500 interceptors. Threats start coming in. You fire 1, then 2, then 5 in a day, then 10. The incoming threats keep coming, and your stockpile shrinks fast. Within weeks, you could use up missiles that were supposed to last for years. So you call the manufacturer and say, produce more as fast as you can. And here is where reality hits hard. You cannot simply flip a switch and make factories produce 10 times faster. There are 3 fundamental reasons why. The first reason is supply chains. An interceptor missile is not made in one factory by one company. It is assembled from hundreds of specialized components, made by dozens of different suppliers, sometimes spread across multiple countries. One company makes the rocket engine. Another makes the guidance computer. Another makes the radar seeker that helps the missile find its target in the air. Another makes the metal casing. Another makes the electronics, and so on. All of these have to be coordinated and delivered to the main assembly facility at exactly the right time. If one supplier cannot keep up, the entire production line slows down, no matter how much money or pressure you apply at the top. When you suddenly need 10 times more production, every single one of those suppliers has to increase their output simultaneously. They have to order more raw materials, hire more workers, sometimes buy entirely new machinery. Many of them are already running at full capacity, making components for other products and other customers. Think of it like a highway with dozens of exits, all backed up at the same time. You cannot go faster than the slowest part of the system allows. The second reason is the skilled workforce. Building a precision interceptor missile is not an entry-level job. It requires engineers and technicians who have spent years learning their specific craft. People who understand how to work with advanced materials, how to calibrate guidance systems, and how to spot a defect before it becomes a failure in the field. You cannot hire people off the street and put them on the assembly line next week. Training takes months, sometimes years. The pool of workers with the right skills is not large. Many are already employed. Some have retired. Some have moved into other industries. So when production suddenly needs to double or triple, factories face a hard constraint. There are simply not enough qualified people to do the work. You can hire more, but those people will not be productive immediately. There is always a lag between hiring and actual output. The third reason is time itself. Every interceptor that comes off the assembly line has to be tested before it can be used. It must be checked for defects and verified to work correctly under the conditions it will actually face. This is not optional, and it cannot be rushed. A missile that fails in testing is a problem. A missile that fails in combat when someone is depending on it is a catastrophe. Testing takes weeks, sometimes months, and it applies to every single unit. So even if you have the components and the workers, you still cannot produce faster than the testing process allows. Supply chains, workforce, and testing time, all three work together to create a hard ceiling on how fast production can increase. You cannot overcome all three at once. It is not a matter of willpower or budget, it is physical reality. Now here is where the economics become important, and frankly, quite unfair. Offensive missiles are simpler. They do not need to be as precise. A basic drone or cheap missile might cost a few $100s and can be produced quickly in large numbers. A defensive interceptor costs $10 to $15 million each. So when an attacker fires a $500 drone and the defender fires a $1 million interceptor to stop it, the attacker loses almost nothing. The defender loses enormously. Do that 100 times, and you have drained hundreds of millions from the defender's stockpile at almost no cost to the attacker. This is why stockpiles shrink faster than anyone expects. The economic math structurally favors the attacker. When stockpiles run low, defenders face choices with no good answer. Use remaining interceptors only against the most dangerous threats, and let smaller ones through. Turn to electronic jamming or alternative systems to reduce the drain, or accept damage now and focus on rebuilding for the long term. None of these are good options. When you are running low, compromise is what you have. The industry is responding. Production targets are being raised, with some systems going from a few dozen interceptors per year to several hundred. Longer term, manufacturers are exploring laser-based systems that fire at the cost of electricity rather than a $1 million missile. But none of this arrives quickly. The decisions made today affect stockpile levels in 3 or 4 years, not next month. So the next time you see a headline about air defense missiles running low, here is what you are actually looking at. The speed at which missiles can be fired is measured in seconds. Hundreds can be launched in a single night. The speed at which interceptors can be built is measured in years. 40 produced in 12 months. When those two timescales collide, stockpiles shrink faster than they can be refilled. That is the real reason air defense missiles are running out. And until that gap closes, it is a problem that will not go away.